Thank you very much for being here tonight at the French Institute. We are very delighted to welcome you for this event, which is organized in the bigger event of the Night of Science in Helsinki today. It's 33 events that are organized tonight in Helsinki for science lovers and everyone who is interested into learning more about science. We are more than 70 organizers of events and partners, and we are very proud to take part in this big event in Helsinki. I'm going to start with a few thank you. I wanted to thank the organizers of the Night of Science, to thank also the Alto DG platform for the exhibition that was just open right before this event right now, that you can of course have a look at after the events. Thank you very much for this partnership and organizing this exhibition. I also wanted to thank and to mention especially the Goethe Institute, because we are organizing tonight this event in collaboration with the Goethe Institute as part of the French and German collaboration, and we're both doing so an event on artificial intelligence. And right after this event there will be a second event going a little bit more deeper onto the questions of artificial intelligence, and so you are of course all welcome to go to the Goethe Institute right after here. And then I wanted to thank, of course, the two men who are here and who are participating in this event. So what is this event tonight? Well, when we thought about what could we organize for this Night of Science, we came, of course, to discuss about artificial intelligence, because it is everywhere. But then we just wondered, what is actually artificial intelligence? What is exactly the definition of it? What is its implication? Am I concerned by artificial intelligence in my daily life? And the answer I can already say is yes. And is it transforming our world today? It is also yes. But then we were wondering on how exactly. And this is why we organized this event on artificial intelligence, on what it is. And the two men here are just going to talk to us about the definition. As it's always nicer to learn by just having some fun, it's going to be also some quiz, and that you can just answer to know what it is, what is its implication, and and the quiz is also going to be, and I'm just giving you some hints there, on machine translation, and machine translation is the topic of the conference at the Goethe Institute right after here. So now I'm going to introduce you. So we have with us Amar Mian, who is a postdoctoral researcher at the Aalto University in the Department of Signal and Processing and Acoustics. He's actually received his PhD from Paris-Saclay University, and his main research area is the development of machine learning algorithm adapted to huge and complex data, as well as the study of their robustness. And I'm definitely already impressed just by saying what you're working on. Thank you very much for being with us tonight. But then, if you already know the French Institute, if you've already been here, that we like to see things from different angles. And so we are used to, of course, and it's so necessary to see it from the science perspective, but we just thought, maybe it could be really interesting to add another perspective of it. And this is where we have Grégoire Rousseau, who's also with us. And Grégoire Rousseau is actually a mix between science and art, because you are an Helsinki-based artist, and you have a diploma both in science, in computer science, and in Master of Fine Arts. So you're also just having this two fields in your expertise. And you are research focusing on electricity as a form of energy in the arts and its social and political implication. You are also a teacher, And so thank you very much for the both of you for being here and to teach us tonight about artificial intelligence. And without further ado, I'm just going to give you the floor just to say before that, before I forget, today it's actually, we are organizing our first event of the year, but as I see many new faces also tonight here at the French Institute, just know that we are organizing events every Thursday on many kind of topics. It can be literature, it can be conferences, it can be meditation, it can be education, anything. So please just follow us on our social media to know what are going to be the other focus, and just know that for the on the 30th of January we are going to organize the Night of Ideas on being alive. That's the theme, and so just be on Facebook just to have all the information on these events. Thank you very much and have a very nice evening. Thank you.
Okay, so I think I will continue a bit in the same as the director. I will first say thank you very much for all of you being here. I hope that you will have the good time. I don't know if we will exactly provide the definition of his artificial intelligence. At least we will try to present some kind of overview, but we will talk about it later. And yes, and again, special thank you to Elena Secarelli, who's been inviting us and proposed the situation that there will be a dialogue between computer science, official computer science, and artists.
Yeah. So I would like to thank everyone who organized this event as well. Elena as well, who isn't there because she's sick, so she's still in her house. And yeah, so we would like today to be more interactive session. We are not just going to lecture you about machine learning. You can have a YouTube video on that if you want. What we want is to have a feedback kind of stuff where you can ask us questions. We will have topics. Sorry, you can have say. And so yeah, interactive session where you can ask if you have questions and we can try to answer. But we will have quizzes if make start.
The one point when we were talking is that the artificial intelligence topic is as wide as interesting. So we thought that it would be an overview, let's say a progressive overview, meaning that the structure of the presentation will be somehow linear, not meaning from easy to difficult, but maybe more from concrete to abstract, or so in some other words, from practical to more theoretical, and then what will be the development of this the practical part of this theoretical advancement. So now there will be a couple of questions that will articulate the flow of the presentation. They should provide some support on the discussions, on the interactive part of the presentation. Do you want to talk a bit about your work beforehand?
Yeah, sure. So as I was presented, I did my PhD in Paris-Saclay, where I was more on signal processing, which is a discipline where we try to analyze signal and process them, and which has seen a huge paradigm shift where we used to use statistics and this kind of mathematical expression, but now we are more and more shifting to a machine learning, which has a specific kind of definition that we might talk today upon. And then I came here in Aalto, where I'm working on using machine learning for several tasks, such as recognizing people in cameras through videos, as well as trying to make a classification of what our brain thinks. So if we can put a machine on top of someone and analyze the electroencephalogram, we can try to classify in some way what the people is thinking. So I'm trying to research on this kind of topics.
Okay. On my side, to situate a bit my practice, I graduated in computer science over 10 years ago. Then at the time there was no machine learning involved, I have to say. So I had to get to know it on my own side. After this first diploma, I got hired by Finnish Academy of Fine Art, where I've been teaching then and established the first space dedicated to electronics and programming. And after that, I went to study myself, and then I became Master of Fine Art. And of course, artificial intelligence has a very special position for me, because my field, as the director said, my field of research is electricity as a form of energy in the art, meaning that usually to find form, artists use their body to find form, meaning that a painting will use the hand, the energy from the body to reach the surface with the brush, and then the painting will come. The sculpture will use the hand and maybe the hammer, and then will kind of hit the stone, and then the form will come. The dancer will use the body. So I noticed that traditional art practice were using always energy from within the body. But electricity is different. Artists can use electricity to find form. The energy does not originate from within the body, but from outside. And this produces a special art practice thanks to energy, electricity in that case. I wrote a book about it 1 year ago. And of course, when we think electricity is as well, can do two things, strong signal and weak signal. Strong signal is what will be converted to produce motion, to produce light, to produce audio, sound waves, to reach our senses. But what electricity can do, electricity is what runs in computers. It was run in mobile phones. This is what I call weak signals, which is more at the information level, at the data level. And when we think of artificial intelligence, it's electricity that produces this intelligence that does not originate from the human body. It's an intelligence that comes from mostly computers, or some form of computers, special form of computers. And this is how I reached to get interested in artificial intelligence. Of course, there is not only one reason why I'm interested in artificial intelligence. There are, of course, like a convergence of many fields all coming together. Because at the same time, I had been working with the idea of machines. What is a machine? I had an exhibition titled Modern Machine that was in Munich a couple of years ago, where I was investigating the hidden part of the machine, what is behind, how does it operate, what are the functions of those. And of course I wanted to go further in that process, and I went to artificial intelligence because of different reasons. Maybe chess was one of them, maybe we will talk about it. And then when we were asked to do this presentation, I thought that maybe we would start with something very simple, in a way very practical, that would somehow relate to art. The form we decided to present would be painting.
So, yeah. So here you have 3 sort of paintings. Which two are true painting painted by someone, Rembrandt, famous painter. And thing is, there's one among them who is not painted by him. How is it possible? And which one is it? What do you think?
Left one.
Like, we will do it like the left one. Who think is the machine one? Yeah. Middle one, and the right one. Yeah, so I think most people think it's the right. Yeah, I didn't count everyone, but but no, it was the first. Yeah, you have to know Rembrandts too.
The process to achieve this new painting in this project called the Next Rembrandt project, they've been scanning all the, not all is maybe a bit too much, but as much as they could, at least paintings by Rembrandt. and they haven't been scanning 3D, which means that the actual painting is not flat. It's really been 3D printed to really respect the, I don't know what is the technical term in painting, but the matter that makes the painting. So even by eyes, when you see the piece in real life, it would even look like with all the shadows of the matter, the paintings and everything. It's really kind of achievement. Of course, in terms of like proper artwork, is it really an artwork? What do you think, Amar?
I would say someone did the programmation and the analysis of all this data. So this is kind of responsible of the output of this that we are seeing now. So I could say we have someone that was involved. So I would say yes.
Yes. But do you think that the actual artwork is more the painting itself or the work behind that?
Yeah, that's a difficult question.
Yeah, but that's why I ask.
Yeah. Maybe we can ask someone.
No, because I actually, like, for me,
for
I
you,
think...
what about you?
Yeah, what about me? Yes.
Yeah, you're the artist.
No, we are. The artwork itself, you know, there is Rembrandt. I mean, we see Rembrandt, it's okay, we know what is a painting, we know the history of painting, it's okay. But like, at least what triggers my interest is more to know how they make it to happen, what make it so special, why is it like that, and not something else. Yeah. What was the process to find the point that we can say, okay, this looks like a Rembrandt. And even to the point that we can make mistakes, we said, oh, I thought it was this one. I think that is more interesting than the work itself.
Yeah.
I mean, what we can see at the first glance.
Yeah, it's interesting because we can see that with this kind of technology, we are able to generate stuff that is irrecognizable from real stuff. And it is question the fact that what is real stuff? Like, if I can have any kind of painting generated randomly through machine learning, can we say they are art? You know, saying? Or like, it also raises the question of like, if you see an image on the internet, can you say that it was real or fake?
This is another topic that we didn't plan, but it's very good.
Yeah, right.
You're talking about deepfake.
Yeah, maybe you have heard of this word, deepfake, which is a process by which we can replace, for those who don't know, we can replace the face of someone on any video by the face of another people. In this way, you can make different people say different things, which is kind of scary. It's also interesting because I heard that with that you can make dead comedians act in movie again.
Yes. Yeah. I would like two things that come to mind, so I think I would like to share. This is the case for the latest Star Wars.
Yeah.
Because I read slightly about it, and I'm not going to say which character is it. Maybe Leila or something. They needed her to do something. She happened to die. Okay. And then they did it with CGI, which is old school technology in terms of how to produce images, and it cost millions. Like really expensive, but then some people did like, look what we do with artificial intelligence, and it was maybe not as good, but still very good, and the price was like not even tenths of the CGI.
There are costs that you can't think of first, because they use a technology which is based on deep learning, which has an important phase of training. We will maybe get to that into later, but the thing is that in this kind of technology, you have the algorithm to learn something, to reproduce, for example, this painting, but you also have the fact that to do that, he has to have a lot of data. So in artificial intelligence, what you have to know is that you can do anything if you don't have data. So artificial intelligence can be more like the link between these two. So what was I going to say again? So yeah, you need data, and you have a lot of data. So for example, deepfake, you can learn what is a face, how to replace it, but you have to have like 10 billions of images. And if you want to process this kind of images, you need a really powerful computer that is able to go through all these images train a very complex model of 1,000 billion parameters, learn them from this data, which can cost quite a lot. So when you say that it costs nothing, is that they use the pre-trained model. Someone had already done that. But to train a model like that, you can say that just in computing power, electricity, and everything, it can cost up to like 100,000 euros. That you wouldn't think about this stuff.
But at the same time, once you have trained it, and if you want more of this character,
yeah.
the return on investment is quite good.
Yeah.
You don't need to redo the things all the time. Once it's done, it's done. Or
yeah,
easier to repeat.
Or you can start from a pre-trained model, which is like most of the machine learning application are done, is that they use a pre-trained model that is available. I guess if you have seen the exhibition, there are some work that was done on AI, Trolley, or this kind of stuff. They use pre-trained models, so they didn't do this training themselves.
Yes. Yeah, this deepfake phenomenon is very interesting, I think. And of course, it's very scary if you think of especially if you think of the possibility to do it in real time. If you're able to actually hack the video stream and then change the face and change the discourse in real time. If someone could do it in real time to hack, like let's say BBC, and say something happened, I think that the social unrest could be proportional to the technological achievement. The second slide we have, well, let's not say slide, but like point we would like to bring, which is still at the very practical level. Since we are talking about artificial intelligence, if we are talking about neurons, then how not to think of the brain and how not to think how to compare the two of them.
Yeah, what he's trying to say is that we use in this kind of technology, AI, what we call neural network, which is kind of an abstraction of what we have in the brain. So in the brain we have biological cells that are called neurons that act in a certain manner. And so when you use neural network, it's a digital replication of this, and we can see some link. But the problem is that there's neurons in both, and what do you think, how many neurons do we have in the brain? Neurons can be, it's a very rough description, but we would say that the number of neurons gives you the computing capacity. It's not true, but let's say it's that. But how many neurons do you think we have in the brain, and how many neurons do you think the AI that is used, for example, in deepfake, are?
You have to use the brain to count how many cells in the brain we have. That's a good loop. Yes. Maybe you can ask yourself, like, okay, 1, 2, 3. No. And the answer is,
Yeah. Yeah, so we are at the point where we have a lot of neurons, which means computing units in our networks, like millions, but the brain has much, much more. In fact, it has this 10 to the power of 9. Which is quite impressive because we don't have the computing capacity to reproduce that yet. Like, we would have to have very big rooms filled with computers that are linked and able to process that, but it's not feasible realistically yet. So, what this say, I think, is that we are still a way to go, and that human is still better, maybe.
Plus, great news.
Yeah.
But just like this is really the maximum. I think that in average is way less than that.
Yeah. Depending on the application.
Depending, but this is like, I mean, when I researched and found some documents already a couple of years ago, it was way less than that.
Yeah.
So I think that usually it's more in this range, but this is really the maximum that has been used.
Yeah, just I want to add that, yeah, I said the number of neurons is important, but it depends on the task you are trying to do. Like, the brain is capable of doing all kind of tasks. I can speak, I can see, recognize people, I can do all this kind of tasks, whereas when I try to use AI, and maybe that's what one of definition of AI would be, is that I'm trying to do one specific task. I'm doing the specific task of driving, or recognizing something, or it can be complex, because driving requires a lot of different stuff. Recognizing people on the street, recognizing the sign, recognizing where we are going. But still, it's one task. If you use an AI that is capable of driving cars, you can use it to, I don't know, drive rockets. It's not the same stuff. While if we have a brain, we can do all different kind of stuff. So, yeah.
Yeah, this is perfect transition for the next point, which I think is slightly more interesting or relevant in the discussion. It actually comes from real life practical use. Those pictures come from the let's say webcam that was in Canada, that was supposed to count coyote and wolf. And the software has been working, artificial intelligence software has been working for many months. Everything was fine. Okay, this is a wolf, this is coyote, and so on. Able to process the data very well. But at some point, he started to not provide good results. It was mixing the two of them. It was not successful anymore. So why the wolf was not properly identified? The snow in the background was missing, the image quality happened to be too poor, and we cannot find out just why the mistake happened. Like, sometimes we don't know.
What do you think? Who is one number one? The first one. Yeah. Number two? Actually, there's no. Who thinks we don't know? Yes, it's everyone. Yeah. Yeah. Okay. That's surprising, right? Like, there's no snow, and now there's no wolf. How can that be? That's because the training, I was talking about data earlier. It needs data, so it can reproduce result that was already on the database. What do you think happened there? They only trained on data that was snow, but there was snow, maybe in winter. And so they tried to reproduce that. And in some way, the machine learned from some abstraction that if there's snow, it's a wolf.
Exactly. It all depends on the context.
So, yeah. What this means is that the data is important. Like, it cannot generalize to something that it hasn't seen yet. And you can understand how it finds a decision rule. In this case, we find through this experience, but if you have a driving car, it is a very complex system. Yeah. When you think about driving, I use this example, but like, you know what you are thinking about and what make you do what you are doing. Like, if you want to accelerate, it's because you know you're on highway, and you can. But if there are some people coming, you stop. But now you learn a machine to do the same. There's nothing that say that for the machine, the rule that you are using are the same. So in a way, it raises some questions and some worries as well. I have another example of this stuff that can be scary. Is that recently, you know, Tesla, it's a car manufacturer that's working on this kind of technology, and they had an accident where they killed someone that was walking, passed over. Why do you think it didn't stop? It was because the person was not on a crosswalk, because the machine always learned that person can only cross where there's a crosswalk. So it was not a person, so no problem, we can go. Yeah, so it's not to scare you, but like to show you that.
just a bit aware with that, like, please cross the road at the crossroad, like Like, don't be stupid. Like, just
Yeah, like this kind of technology is not magic. Like, it's not as like we are talking about. Like, the brain can do many things. It can react to something that it hasn't seen. Maybe the machine cannot yet.
Again, the perfect transition to the next point. After understanding the importance of the context of the thing that we are looking for, which is maybe actually as important as the thing we are looking for, isn't it? Or everything that is around is as important. When we look at the pedestrian, where the pedestrian is as important as the pedestrian itself in the decision process.
Yeah.
So in the continuity of this idea, how to take decisions, and especially a critical decision where life is at stake. Like, if we are talking about the vacuum cleaner or how to take better photograph, then it doesn't matter that much if there is some mistake or if the vacuum cleaner is stuck in one corner for half hour. At some point, it will go out and the job will be done. But when you are in a car and that there is a critical situation and that the decision is okay, let's not think of bad cases, but when the situation is critical and still the decision has to be made, how to achieve this decision for the best. So the best has to be defined. I think that the best example to illustrate this decision process and how difficult / impossible to resolve, there is this very famous example which is called the Trolley example by Philippe Afout in 1967. The situation is very simple, as dramatic as simple. There is a train. Actually, maybe how many of you know this example? Yes, everybody. So that will be a good story of most of the people. So there is the train coming like at very high speed and is on a track. And if you don't do anything, then the train will just hurt those 5 people. That is very sad. But it happened that you're here. You personally, you are there, and you can activate one switch, let's say one switch, and the train, instead of hurting 5 people, will hurt only 1. So you have to be very utilitarist, and your decision is, are you going to activate the switch so that it's going to hurt only 1 person, or are you just don't do anything and it's going to hurt 5 persons? In that situation, I think it's close to 90% of people that say, yes, I will activate the switch. Just one small parenthesis. To be really critical, I think the point is not to hurt but to kill. You know, there's no way back. Like you kill the person. So this is decision number 1. You do something, and instead of killing 5, you kill only 1. Now the second situation is that you are on the bridge with a friend, kind of like a close friend, and the way I put it is that the train that goes extremely fast has a kind of sensor that if there is a shock, then the train will stop at once. So your decision or the situation that you're in is either you don't do anything and then 5 persons will be killed, or maybe you can just push your friend so that your late friend will hurt the train and the train will stop, and only 1 person will die instead of 5. If you think like very utilitarist perspective, is the same decision, like killing 1 person or the other.
You can always jump, but like it doesn't change the situation.
Of course, you can kill yourself. Yeah, of course, it's like that.
But like it's not like it raises some questions. I don't think there's a definitive answer. Is depend on like. But when you are driving a car, designing a system that is driving a car, you have to answer this kind of question. Like someone is just like crossing the street, and you have to either stop, or maybe if you stop too soon, you will endanger the passenger. And you have to design a system that will think about this ethically and try to find an answer that like minimizes the amount of hurt.
Exactly. And in that regard, I read one paper, extremely interesting paper, which is called Machine Learning and the Law, 5 Theses by Thomas Berry. By memory, I think it was published by Zurich University. And the most interesting point, he proposed one solution on how to solve those critical situations. So, do you think that the proposition of this lawyer, very competent lawyer, was, okay, we cannot do anything, we just wait for more data, as you said maybe, to find more suitable models? Or we use random-based decision, or in any doubt, in case of we cannot take decision, then as early as possible we just stop everything.
So it's not about what you think it should do, but more like what do you think the people behind this kind of system are going towards.
Yes, because this is the question of responsibility. Let's say a simple case than the trolley example. Let's say you're in the car is driving, and the situation is that either you're going to crash into a kid or the car has to take the decision to run into the tree. This kind of situation, who is going to be responsible for the accident? The person who drives the car, the person who bought the car, the engineers who designed the artificial intelligence, the company who hired the engineers, or nobody, or everyone? How to solve? Because someone will have to answer for this accident.
The company who designed the artificial intelligence car.
Yeah, this is like a very standpoint.
Those kind of accidents.
But okay, but at the same time, we would like maybe to find more what kind of solution we can, because the definition of accident is that we cannot predict, is the unexpected, something we cannot plan in advance. Ah. Say? Three.
Last one.
Okay. Oh, yes. Very radical. Xenia, you?
No, I just wanted to say what's related to the trolley puzzle, that there is, I mean, with AI, as I understand, it does what it's supposed to do. So it will not think of an option to kind of scream at people and kind of find a way to tell everyone to get out of the track. So
yeah, but we can plan, like it's unpredictable, but you know that it can happen at some point. So you have to think of some way to.
Can you know? Like,
no, you can't prevent anything. Like it has already happened, as I said it. The thing is that having accident on the road is not so unpredictable. You know that it can happen at some point.
But we don't know how. So that's.
Yeah, that's more the question.
what's it on?
Number 3. Okay. The answer is to use random-based decision, because at the end of the day, it's impossible to do good. And actually, one in all, maybe the closer reaction to human, it is like very, where the time to take the proper decision is so short that maybe that's what the proposition of this lawyer is to implement more random-based decision. Computer can achieve extremely good random numbers, and why not, let's say that we take these random numbers to take the decision for us. Something that the lawyer says that is very important as well when doing this kind of things is to make the information public, to let know the people that random-based decision can happen. Otherwise, it's not fair.
And it's not related to what you think it should do or not. Like, it's not a philosophical question. It's more like practical, and that's what it's tending towards. And you can agree or not, but we are just trying to give you information about this. Yeah.
Yeah, I was just thinking about the random based decision. If the computer makes a, well, having read about singularity, and I'm thinking just to, like if the computer would become like super intelligent? Will this kind of be a backdoor to use the random-based decision to overlook all the kind of the safety issues that you might have written into the code of the computer or the AI to not hurt or whatever, and then kind of, oh well, I'm just applying the random-based decision here and maybe do some damage, or if just like speaking about the
I think a very interesting point. I think that talking about singularity in that case is only a speculation. So of course, yeah, we can speculate, but if I would like to speculate, maybe we can discuss, is that maybe the logic will be if car produces so much accident, the only way to stop accident will be to stop the cars.
Yeah. Or even in. Well, yeah, maybe. Yeah.
Well, we are not at the singularity
of
yet.
course.
And what I want to say that the randomness is not based on what it should do. Like it's not you can set A, set B, set C, and they're all equal. Like it's randomness controlled in like you add some randomness to decide between two situations, but like the two situations are set. Like, but I get what you're meaning about singularity, but right now we are not at this yet.
Yeah, so I was thinking for the high-tech companies like Tesla, that when they produce something related to safety issues, they probably will be able to consider all the consequences, like some car accidents. They can simulate the situation, and then they can, you know, come out with some solutions based on the code. So they can have all the possibilities they can think beforehand, before the accident happened. So they can have the solutions in that data if that happens. If that actually happens in real life, they can have the solution based on that predicted solutions in the database.
No.
The variables are nearly infinite.
Yeah, but something
What you are saying that there is one good way of action in any kind of situation in that case. It's like, and that we learn this good action. But when you are training some model, you tell it what is good and what is bad, I guess. Like this is good driving, this is not good driving, and it learns it. So you would set a rule through your data that you have decided would be right. In this case, the randomness comes from the fact that so you will be responsible if you do that. Like you're the person who has trained the model. He used this kind of data more than this one, so he made the model biased in that situation. Where if you had some randomness, like there's no liability because it's that like it's like an easy solution. In fact, it's like we have a so complex problem and we don't know what to do.
But maybe to continue a bit, I mean, if we're talking about that, we should not lose perspective that Tesla and those cars, they are there to make profit. So they won't do anything that will hurt their way of making profit. I mean, if they would sell a car that will officially tell you that in case of whatever, we will crush you, I don't think that is a good solution for them.
Well, just give the capital of lawyers.
The what?
Lawyers. Capital of lawyers to talk to calculate the law in case of any kind of trouble. So it could be the case actually.
How to react?
How to react on this situation.
Yes. How? Yeah. I didn't
get. You can involve lawyers. Lawyers can analyze what can be, the disaster.
Yeah, but exactly. Yeah, but lawyers, they don't have answers for that.
Yes.
They will raise the risk. What is the most risky stuff?
You mean insurance? Yes. Yeah, but it comes to what I said. It's about profit and how to not lose money at least. Yes, exactly. But the essence is the responsibility, because who is going to pay is who is responsible. No, I hope at least. not always.
Yes. Our country is working on some kind of global standard that everyone would use in this subject.
Sorry, can you repeat?
Like,
yeah.
Our country is working together.
Yeah, they are trying to follow
global standard that everyone
they have to implement. Yeah.
Okay. Because I was thinking maybe, for example, Tesla would change their code so that they could use it in business to sell that, hey, our car could prioritize your life. Buy it.
Yeah, actually, there's not so many regulations. That I think the thing with this kind of technology is that it happens so fast. Like, we got from the idea, like the idea is old, but from the idea of it's possible to actually doing it quite fast. So, like, society is trying to recover from this, trying to catch up, but like, they have already released this kind of situation. Like, they are not allowed yet to drive by themselves, like only in controlled situations. So there are some regulation now, but it's up to the countries and trying to find a way that we have to find. But we don't know if there is, let's say, like, even if you put some rule, if I will just do a side on this, is that even though you set rules, you are not sure that companies will respect them. Like, I would say...
yeah, but that's what it has to be open source. It has to be open at least.
And that's what I was coming from the side. Parenthesis is that if you do this kind of stuff, you have to what we call open source, which is that you release the data and the algorithm that you used in order to do this kind of technology, so that anyone can try and find if there are some biases and this kind of stuff, and they can respect this or not. If it's not open source, we don't know. So it is a really important topic when we talk about AI and this kind of responsibility.
About the random-based decision, was this implemented only in the car situation, or was it already implemented?
As I said, it's a paper published by the lawyers that so it's more a proposition. It's a proposition.
Proposition for the car situation.
Yeah, exactly. Yes.
Yes. I was thinking just like using AI in some different situation, not like just like something different, and then using random-based stuff on there, like that. Maybe random-based decision isn't like a good solution for every situation. Not maybe in this kind of.
I think it's when the question of responsibility is the core of the thing, and as Amar said, it's not, as you said, it's not like randomly deciding between
random stuff. Like,
the car goes totally banana. Yes, so it's more. Yes.
I just add something, because it's interesting that you said the question comes from a lawyer, because the legislation, let's say, because lawyers have to make a lot of decisions, and there you have to really use the text, so the data for them is mostly text, but then car driving is more a complex situation where you make decision maybe based on different intelligences in your body, and that's the complexity. But it's very complex topic for sure.
Yeah, but I can forward the document for whoever would like to read. But the starting point of the paper is that the way we perceive harm when it is being done does not depend on the intention of the person giving the harm. This is the starting point.
Then there's also situations where you do the right thing, but still are the guilty party in a legal sense. Like if someone in front of you slams on their brakes, you drive into them, and technically it's your fault, even though. So that sort of stuff is what an AI can. In its eyes, it's just bad to drive into stuff. So you might suddenly swerve and hit some other stuff. It can go really haywire if you wanted to avoid every fault.
Exactly. We go to next. Is the question of model. We are a bit short in time, so I will skip the chess. And
yeah, no, just a few words that you may have heard. Just we can explain a little bit. You may have heard of this AlphaZero or DeepMind stuff.
Just try it.
Yeah, like we can just talk 2 minutes about this. Who has heard of this AlphaZero? Yeah, not everyone. So just to explain, it's an algorithm developed by Google that allow it to play strategy games such as chess or Go. So it's like you have your board, like a set of pieces that you have, and it finds an action to take, and you do that many times. And it happens so that this AlphaZero can beat everyone in the world.
Yes, but the thing is that the previous non-AI based chess engine could still build the best in the world.
Yeah.
But what happened?
Not Go. Yeah.
And not Go. You're right.
Yeah.
Yeah.
Like, yeah, because Go is such a complex game. I don't know if you have played it. I played it a few times. It has simple rules, but that makes it a very, very complex game. You have so many strategies that you can't like have non-AI based strategies. Like you can't say a machine try every combination. There's too many, like more than atoms in the universe.
The same for chess.
Yes. The same for chess, but the thing is that there was no AI, no like computer based on strategies that could build someone. But using this deep learning technology with what we call reinforcement learning and this kind of stuff, they happen to beat the world champion on Go on several occasions, which means that this kind of technology has improved a lot. And what's interesting is that we come back to this first example of this portrait, like who's the author, but now who's the player? Like the machine is playing, but how does it decide which strategy is done? Like what's happened is that the machine doesn't really use any Go strategy at all. Like you would expect that in some situation you would do that because it's like the culture of the game, I would say.
If it happens to win, then it happens to have some strategy. Yeah. Maybe something we don't understand, but still it's having a way of playing and following
just
the plan.
that we don't understand it, like at the human level. Like maybe he's thinking, if we can say, think about this technology, about some stuff that we haven't realized yet about this game.
I mean, I can talk about chess. As you said, the board games are perfect for artificial intelligence to test because it's a limited space, it's very clear rules, and the result can be very easily assessed. So this is what somehow defines like a good database: limited space, very clear, precise rules, and very good way to assess the quality of the results. But in comparison, what really amazed me about the AlphaZero is that they only gave the rules of the game. Compared to the traditional chess engine, they said to the engine the queen is more powerful than the pawn, and the rook is better than the bishop. And they use a heavily database for opening, database for endgames, that the computer can refer and implement. Really for DeepMind, AlphaZero, even if Google didn't release the full specification, the full technical specification, no opening database was provided. It was just AlphaZero playing against itself for 2 days, something like that, playing intensively, like 1 second games, like maybe one move, 1/10 of millisecond, and then able to find the pattern recognition, what looks like being better, what looks like being not so good, how to approach position in a different way. And just to conclude, when grandmaster were looking at chess game played by traditional way of thinking chess by computers, they were able to say, okay, this game is played by a computer. Because in traditional thinking, the tactic as a strategy. It was brutal force. The more they were able to calculate, the better it is. But for artificial intelligence, it's different. Nowadays, Grandmaster cannot say the difference between human playing and artificial intelligence playing, which somehow means that the computer has a strategy, which is next level.
Yes, and just to conclude, this example also illustrates that we don't always, I talk about data, we don't always need data. We can find a rule that represents our problem and use this rule as training, in fact. So this chess, for example, or Go, for every situation you have a score, like this is a better position than the other one. Like for example, in Go, it's like the area that you have on the board. And just with that, he can learn. So like, it's not always about data, you can find some other way to train your AI.
So we would like to, I think that we will have to conclude on the different, in the differences between those two models that we call traditional programming and machine learning programming.
Yeah. Okay, so since I did a lot of programming in my research life, I guess. The idea that you have a problem that you want to solve and you program the machine to do the task for you. And this can give this kind of flowchart where you have some data that is coming. For example, in image processing, you have, for example, when you take a photo, you have an image, and then you can program it, for example, to make some filtering to reduce the noise or this kind of stuff, or to like Photoshop or whatever you want. And you have an answer that's based on some rules that you have decided that's what's best. That's what is traditional programming. Whereas in machine learning, we have different paradigm, I would say, which is, yeah, this one, where actually I told about this like a lot today, is that you have the answer and the data, and then you learn the rule. Like, it's another paradigm. Like, it's reverse. That's quite strange, you would say. Like, I want to do some task, but it's so complicated. I think this technology arises because we had some tasks like speech recognition, self-driving car, that were impossible to do on a rule-based decision problem. Like, I couldn't find some rule that would allow me to find an answer that was satisfying. So what we say is that we have a lot of data and we can learn the rule. We don't understand how it does it, but we learn the rule. And that's what's happening right now, is that thanks to new technology that allows you to do that, to process a lot of data, you can find a rule and then apply them on another data set, which is your problem.
And now, 1 hour lecture on the perceptron.
We almost have the time.
Okay. What to say?
We have a couple of minutes more.
That's okay. Well, just we have a lot of stuff to say tonight, but maybe we can just say that it all arose when biology also evolved. So if this kind of technology is the result of first biology, where they were trying to reproduce a model of a neuron. Actually, it was in 58, I guess. 58, where they put a frog and they try to analyze how the brain of the frog works. And so they find these neurons and find this model that allows to reproduce what a neuron did. So you have an input signal, which is electricity, and it can do some minor change to that, and etc. And so it was left at that by the biologists. But some guys thought that maybe we can reproduce it in computers, and so they try to reproduce this kind of neuron just from data. So now it's not electricity, but it's numbers that are represented in a computer, and you have inputs, outputs in the same way that they didn't think would be able to resolve these tasks, a lot of tasks. So we had what we call AI winter, so it was left because we didn't have the computing power, in fact. That was the main problem. But nowadays, why do you hear so much about AI? It's because the computer have improved quite a bit. We have processing power with the rise of what we call GPU, which is graphic processing units, which were used for like computer games at the beginning. But the thing is that they can compute a lot of stuff very fast and in the parallel. So they can do several stuff on the same time. And you can see that I guess you call it the calculation per second. Yeah. So the number of calculation you can do per second have exponentially grown. And then at some point we were able to use this kind of model that we thought were useless because too complicated. And it was like 10 years ago, like we reached the gap where now we can use it. And that's why you hear about.
Just to make sure, when you say it's logarithmic, in here the scale is linear, which means like, okay, this is every 5 years. But in here, one step above is times 100.
Yeah.
So what looks like linear is logarithmic. So exponential. Sorry.
And yeah, so that's why you hear about this AI stuff. That's what I wanted to say.
And then you will keep on hearing about it, maybe some other time, maybe next time.
Well, you're going to hear about it actually in half an hour at the Goethe Institute, because there's going to be the conference on machine translations. So thank you very much for this very interesting discussion and for everything that you've taught us. I think we can definitely give a round of applause.